సిస్టమ్ అయితలేదా? ఓకే. Okay. Good afternoon. Are you able to hear my voice? Am I audible? Okay. Let us start today's class. Now, before going to start the yesterday's continuation class, first we'll discuss about what we have done in the last class. Yesterday, we have started the improper integral topic, and we are in improper integral. After completion of definite integrals, we have started the improper integral. Improper integral is one of the type of definite integral. In general, definite integrals are two types. One is proper, other one is improper, based on the function f of x and the interval a comma b only. If a comma b limits are finite, function is finite, then the integral is proper integral. Otherwise, improper. Otherwise means the limits are infinite, or any one of the limit is infinity, function is infinite, then the definite integral is called improper integral. Again, improper integrals are two types, mainly three types, but we are considering only two types. Only limits are infinite. Any one of the limit is infinity, both limits are infinite, the function is finite. Function is finite. And in this case, the improper integral is called first kind improper integral. Suppose limits are finite, function is infinite. Then in this case, second kind improper integral. All are infinite. Then improper integral of third kind. But we are considering the third also under first only. So that is why we have written only two types, first kind and second kind. And also we have seen the method of evaluation of improper integrals. For integral, only one of the limit is infinity. Only one of the limit is infinity. Then we can go for direct integration, no special method only, normal integration method only. Suppose both limits are infinite, we cannot do the integration directly. In this case, we write the integral as sum of two integrals, minus infinity to some point a plus a to infinity. We check whether these two convergent or not. These two are convergent, the main integral will be convergent. Anyone is not convergent, this is not convergent. In the same way, for second kind improper integral also, only at one of the limit a to b, x minus a dx. Now this function is infinite only at this point, so we can go for direct integration, no special method on it. Integral a to b 1 by b minus x dx or x minus b. This function is infinite only at this point. We can go for direct integration. Suppose integral a to b 1 by x minus a into b minus x dx. Now in this case, this total function is infinite at both endpoints of the interval or limits of the interval. In this case, we write the integral as sum of two integrals, integral a to c plus c to b, such that a less than c less than b, or like this. We check whether these two convergent or not. These two are convergent, this will be convergent. Other case also, we can write the integral as sum of two integrals, integral a to b 1 by x minus c dx. This is infinite at x equal to c in closed interval a comma b only. Inside the interval, at some point it is not defined, not continuous. Then we write the integral as integral a to c, c to b, and then we check the convergence of these two only. These two are convergent, this will be convergent. Otherwise, it is not convergent. Okay, after this, we have done the some problems. Next, we continue the problem sum. So yesterday we have done the three problems. Next, it's continuation, problem number 4. And today's date is 15, 9, 20. Now I'm writing the next continuation of the problem. Problem number 4. If integral 0 to infinity 1 by x square plus 4 into x square plus 9 dx equal to k pi, then k equal to option A 1 by 60, option B 1 by 30, option C minus 1 by 60, option D minus 1 by 30. Now it is the problem. It is a integral along with the limits. The integral limits are given. And if you observe the limits, one of the limit is infinity, that is the upper limit is infinity. At least one of the limit is infinity, or both are infinite integral. That too, it is the first kind improper integral. But out of two limits, only one of the limit is infinity. So we can go for direct integration, normal integration method only. No special method here on. Now integrate this function 1 by x square plus 4 into x square plus 9, and then evaluate the integral. After getting the value, we compare that value with k pi, and then we write the value of k only. Okay. But inside the integral, this function is like this. Suppose integral 1 by a square plus x square. Directly we can add the integral of this function because it is standard form only. 1 by a square plus x square is 1 by a tan inverse of x by a. But not only single function, we have a product of two factors here, x square plus 4 into x square plus 9. Now in this case, if you write the partial fractions, then we can do the integration directly by using this standard formula only. So let us write the partial fractions of this. To write the partial fractions of this, write the direct shortcut formula. 1 by x minus a into x minus b. In the differential equation also, I wrote this formula while doing the general method on particular integral of differential equation. In the denominator, we have two linear factors. So we write the sum of the two terms. We can start with any one of the factor. I'm starting with x minus a factor, and then write the difference of these two constants, a minus b, plus in other term, we write the another factor x minus b into difference of these two constants, b minus a. It is a direct formula to write the partial fractions of the product of two linear factors only. But always it may not be x minus a, it may not be x minus b. Sometimes it may be like this also, x plus a into x minus b only. Even though it is x plus a, we should write this in the form of like this. To write the x minus something, we write the x minus of minus a. And we follow the same above formula. If this is plus also, we write this as x minus of minus b only. And then we follow the same method only. But we cannot use this for this only. Okay, for our function, other formula is like this: 1 by x square minus a square into x square minus b square. Now, write the another formula for our function only. If you observe this function, it is similar to the previous one only. 1 by x minus a into x minus b form only. But in place of x, we have x square. In place of a, we have a square. In place of x, x square. In place of b, b square only. Right? So we follow the previous method only for this also. Just replace x with x square, replace x with x square, and a with a square, b with b square. That's all. We get the partial fractions of this one. 1 by x square minus a square into difference of these two constants, that is a square minus b square, plus 1 by x square minus b square into difference of constants b square minus a square. That's all. Right? In the first one, if you replace x with x square, a with a square, b with b square, so that we get the partial fractions of this one. Now we use this formula for our problem only. We use this formula. But in our problem, both are plus only, x square plus 4, x square plus 9. So to use this formula for our given problem, we should write the x square plus 4 as x square plus 4 as x square minus 4 like this. So we can use this formula, this box formula. Right? Now let us write our given problem. Now k pi equal to integral 0 to infinity. I'm writing the 1 by x square plus 4 into x square plus 9 dx, or directly write this as 1 by x square minus 4 into x square minus 9 dx, and then we write the partial fractions. This is equal to integral 0 to infinity. Now the first term like this, second term like this only. X square minus plus 4, I am writing directly. Next, minus 4 minus 9 plus 1 by x square minus this x square plus 9 minus 9 minus 4 dx, which implies k pi equal to minus plus 9 minus 4, 5 here, minus 5, then 1 by 5 is common, 1 by 5 is common, 0 to infinity, inside the brackets 1 by x square plus 4 minus 1 by x square plus 9 dx. Now up to here the partial fraction is computed only. We can write the integral of this directly. We can write the integral of this directly. It is in the form of 1 by a square plus x square, 1 by a square plus x square form. Is equal to 1 by 5 into integral of this is 1 by 2 into tan inverse of x by 2 minus 1 by 3 into tan inverse of x by 3 from 0 to infinity on, which implies k pi equal to 1 by 5 into, for upper limit, 1 by 2 into tan inverse infinity is pi by 2. This is pi by 2 minus 1 by 3 into tan inverse infinity is pi by 2 minus lower limit tan inverse of 0 minus 0, 1 by 5 into pi by 4 pi by 6, pi by 4 pi by 6. Now 6 minus 4, 2 pi. This is equal to 212 pi by 60. Therefore, k equal to 1 by 60. Like this, we can use the direct formula to split into partial fractions, and then we get at the value of the integral. It is problem number 4. Next, we go to the problem number 5. Problem number 5. The value of the integral minus infinity to plus infinity 1 by 1 plus a square plus x square power 3 by 2 dx is Option A, 1 by 1 plus a square. Option B, 0. Option C, 2 by 1 plus a square. Option D, 1 by 1 plus a square power whole power 3 by 2. Now, this is the integral. We are given integral along with the limits, definite integral. But for this definite integral, limits are infinite. So it is improper integral. Because of the infinite limits, it is improper integral of first kind improper integral. And for both limits, infinite. So this is first kind improper integral. Now we evaluate this integral. In every option, some finite value is given. In every option, finite value is given. So it is convergent integral because of finite value, finite value, finite value. This integral value is one of these only. But we are asked to find that value. So we evaluate this. Just look at this. We can add the integral of this. We can add the integral of this. We can add the integral of 1 by 1 plus x square. We can add the integral of 1 by a square plus x square dx. And also we can add the integral of 1 by a square minus x square. But here we require the integral of 1 by a square plus x square power 3 by 2. This given integral is in the form of like this. Not only a square plus x square, here we have one more constant, 1 plus a square on. 1 is constant, a square is constant, so we can write the 1 plus a square as some constant b square. Both together also some constant. So the function will be 1 by b square plus x square only, power 3 by 2. So this is in the form of like this. For this we have formula, 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 for this no formula directly only. So we can do this type of integral by substitution method only. By using one of the trigonometric identity, there are three types of trigonometric identities: sine square plus cos square equal to 1, secant square minus tan square equal to 1, cosecant square minus cot square equal to 1, like this. So using one of these, if we have a square minus x square, then we can use the first identity, sine square theta plus cos square theta equal to 1. But here we have a square plus x square. Because of a square plus x square, we can use the other two quantities, other two trigonometric identities only. Either secant square plus tan square or cosecant square minus cot square. But we are habituated with the tan and secant only. So we can use the second trigonometric identity, secant square theta minus tan square theta equal to 1 only. So we can write a secant square equal to 1 plus tan square. If we have 1 plus x square, then substitution will be x equal to tan theta only. But a square plus x square means then x equal to a tan theta only, like this, right? If we have b square plus x square, then substitution will be x equal to b tan theta only. It is a method. Okay, let us do the problem. It is an improper integral. Let I equal to integral minus infinity 2 plus infinity 1 by 1 plus a square plus x square whole power 3 by 2 dx. It is a given integral. It is an improper integral with two infinite limits. This integral limits are in the form of minus a to plus a. In general, the limits are minus a to plus a, then we can check the function is even function, odd function only. We have written this for proper integral, but for this improper integral also, we can use one of the result of this property only. This property of definite integral works only when function is even. If the function is odd, then the property doesn't work only. But here, 1 is constant, a square is constant, x square is even function. So 1 by this total function is also even function. Because the even function directly we can add it 2 times only. For odd function, in the case of improper, we cannot apply this property. Then I equal to 2 times integral 0 to infinity 1 by 1 plus a square plus x square power 3 by 2 only dx. Since this is even function. Because the even function, I wrote like this only. Next, this is equal to 2 into integral 0 to infinity 1 by b square plus b square plus x square power 3 by 2, comma. Here we are assuming the 1 plus a square as b square only. 1 plus a square as b square. Like this. 1 is constant, a square is constant. 1 plus a square is constant. Instead of this 1 plus a square, we are taking the 1 constant b square only. Now this is convenient for substitution method only. That is why we are writing like this only. So let us take the x equal to b tan theta only. Put x equal to b tan theta, which implies dx equal to b into secant square theta d theta, and the limits. From x equal to b tan theta, we write the limits of new variable. The old variable limits are 0, infinity only. If x equal to 0, here tan theta equal to 0, then theta equal to 0. X equal to infinity, x equal to infinity, tan theta equal to infinity, then theta equal to pi by 2. As x varies from 0 to infinity, theta will vary from 0 to pi by 2. Now we substitute all this in this integral only. Now I equal to 2 times integral 0 to pi by 2, 1 by, in place of x, we write the b tan theta only. So b square plus b square tan square theta power 3 by 2. In place of dx, write the b secant square theta d theta only. We simplify this, which implies I equal to 2. From the numerator, b is constant right outside. From the denominator, b square is common. 2b divided by b square power 3 by 2 only. Integral 0 to pi by 2 secant square theta divided by 1 plus tan square theta power 3 by 2 d theta only. Equal to square get cancelled. That is 2 get cancelled. B power 3 becomes here 1 by b square. 2 by b square integral 0 to pi by 2 secant square theta divided by 1 plus tan square is secant square whole power 3 by 2 only. Which implies I equal to 2 by b square integral 0 to pi by 2. This power 2 get cancelled. Secant power 3 in the numerator secant square with the power 3 get cancelled. 1 by secant. It is a leftover function. So 2 by b square into integral of 0 to pi by 2. 1 by secant is cos theta. So 2 by b square into sine theta from 0 to pi by 2. Therefore, I equal to 2 by b square into sine pi by 2, 1 sine 0, 0 equal to 2 by b square. But b square is same as 1 plus a square. It is the answer. So by substitution method, we can do this problem. If we have 1 by a square plus x square, directly we can substitute x equal to a tan theta only, but 1 plus a square only. 1 is constant, a square is constant, 1 plus a square is also constant. That is why we are taking the another constant b square to get our convenient form, b square plus x square form. Problem number 5. This is problem number 5. Now we go to next problem. Last problem for improper integrals. After that, we start multiple integrals or more than one integral. Problem number 6. If f of a equal to integral 0 to infinity e power minus x into sine ax divided by x dx, then f of a equal to option A cot inverse of a, option B a pi by 2, option C tan inverse of a, option D minus a pi by 2. It is a 6th problem. It is a definite integral. One of the limit is infinity. It is upper limit is given as infinite. So it is improper integral. Because the infinite limit, it is improper integral of first kind. Only one of the limit is infinity. So we can go for direct integration. No special method on that. In every option, some finite value is given. Therefore, it is convergent integral only. Just we are asked to find the f of a only. So f of a equal to cot inverse of a, tan inverse of a, or a pi by 2 minus a pi by 2 only. We know the integral of e power ax dx. We know that the formula for integral of sine ax dx. And we know that integral of 1 by x dx only. We know the directly formula for these integrals only. And if we have integral like this, e power minus x into sine x dx, we can write the integral of this by using the direct formula for this also. And if we have e power minus x into cos also, we can integrate only. But here the problem is given like this, e power minus x into sine ax divided by x dx only. Because of this 1 by x extra function, we cannot integrate this only. We cannot use by parts formula, we cannot integrate this only. So this is not integrable directly on. Now in this case, we can do this problem by two methods only. Just think about this. Just observe the limits and you can get the method also. If you observe the limits are in the form of 0 to infinity. It is improper integral. Laplace transform is also one-sided Laplace transform or unilateral Laplace transform. One-sided Laplace transform or unilateral Laplace transform only. For that Laplace transform also, the limits are 0 to infinity only. So we can do this problem by Laplace transform method or some other method only. We do this problem by both methods so that you will know the method for this. Only because of 1 by x term, because of 1 by x, only because of this 1 by x, we are unable to integrate directly only. If we don't have 1 by x, then directly we can integrate it. So if we can eliminate this x or 1 by x, we can integrate directly only. By one of the technique or one of the method, we can eliminate 1 by x and we can integrate this only. That is one method. Or other method, we do this problem by Laplace transform only. Laplace transform also only. So let us start with the first method. Method 1 is Laplace transform method. method 1 Laplace transform method on LT method. Now, since integral 0 to infinity e power minus st into f of t dt equal to L of f of t. This definite integral is the Laplace transform of the function f of t equal to f bar of s. Input function is f of t, output function is function of s, f bar of s. This is the standard integral or Laplace transform of this function. It is using the Laplace transform also we can evaluate some improper integral of the type 0 to infinity only. Using Laplace transform also we can evaluate some improper integrals of the type 0 to infinity only. When this Laplace transform of the function exists. For this type of integrals, the Laplace of this f of t is possible. We can get the value of the like this integral sum. Okay, let us write our given integral. Given f of a equal to, let us write this as some capital without any confusion. Capital f of a equal to integral 0 to infinity e power minus, I am writing the x as t variable, e power minus t into sine a t divided by t into dt. I am writing this given integral as like this. It is a definite integral. So x is a variable of integral variable is x only. Here integral variable is t. Whatever the variable doesn't matter, its value is same only. Because we are habituated with the variable t and s in the Laplace only. That is why I am writing the given integral in terms of variable t. It is the only difference. Nothing is there on. Right? Which implies f of a equal to. If we compare this given integral with this Laplace transform, we can find some difference only. In place of f of t, we have sine at by t only. It is e power minus st. It is only e power minus t only. In place of s, we have 1 only. So this is f bar of s. In place of s, we have 1. So f bar of 1 only. So this output is given by L of sine at divided by t only. The value of this integral is given by Laplace of this function only. But in place of s, we have 1. This output is finally function of s, but here output should be in terms of 1 only. So this s equal to 1. In place of s, if we write 1, then we get the integral value on it, which implies f of a equal to, but Laplace of sine at by t is tan inverse of a by s, s equal to 1. Therefore, f of a equal to s equal to 1, this becomes tan inverse of a. That's all. This is the answer. Here we can apply the division by t property on. If L of f of t equal to f bar of s, then L of f of t by t equal to integral s to infinity inside the integral L of f of t ds. If we use this division by t property, then we can get the Laplace of sine at by t only. By using this, if we find the L of sine at by t, that will be tan inverse of a by s. So L of sine at by t equal to tan inverse of A by S. By this property, if we find the Laplace of sin A t by t, that will be tan inverse of A by S. So it is a method. So using Laplace transform, we can evaluate the improper integral of the type integral 0 to infinity. This type of improper integral will be evaluated by using Laplace transform also only. Right? Now this is method 1. Next, method 2 only. Now we are going to next page. Method 2. The method 2 technique is differentiation under integral sign. Differentiation under integral sign. Now using this technique, we try to eliminate 1 by x function inside the integral and then we evaluate them. First we have the differentiation under integral sign. If f of x comma alpha x comma alpha, this is not infinity, alpha. Infinity means like this, alpha means like this. If we bend like this, then this becomes infinity only. This is alpha, this is infinity only. Alpha, infinity. If f of x comma alpha and dou by dou alpha of f of x comma alpha are continuous functions, of x and alpha, then d by d alpha of integral a to b of f of x comma alpha dx equal to integral a to b dou by dou alpha of f of x comma alpha dx. This is the result, comma, where a and b are constants independent of alpha. A and b are constants independent of alpha. This is the differentiation under integral sign result. Inside the integral is with respect to x only. Whenever integral is with respect to x and it is a function of x and alpha, that is here alpha is parameter only. Alpha is parameter only. And if we differentiate this, integral with respect to parameter, not with respect to variable integral x only, we are differentiating this with respect to parameter only. And this will be written as like this only. That is, when you shift this d by d alpha into inside, that becomes partial derivative, because f is a function of two variables here. When this ordinary goes to inside, that becomes partial because of the two variable function here on. Using this result, we evaluate that integral only. Let us consider given integral. Here given integral is f of a equal to given f of a equal to integral 0 to infinity e power minus x sin x by x dx, e power minus x into sin a x by x dx. This is the integral with respect to x only. So other must be parameter. Here a is parameter. We treat a as parameter only. To eliminate this x, we should have here x only. To get x here, we are treating this as a function of two variables a and x only. When you differentiate this with respect, when you differentiate sine ax with respect to a, x will be constant. In such case, we can get x here, so that x will get cancelled only, which implies d by dA of f of a. We are differentiating with respect to parameter a, 0 to infinity e power minus x into sine ax. Sine ax divided by x dx, which implies d by dA of f of a equal to, shift this d by dA into inside only. We are differentiating with respect to parameter a, so other variable x is constant only. So inside the integral, e power minus x by x is constant. This is written as dou by dou a of sine of ax dx equal to integral 0 to infinity e power minus x by x into derivative of sine ax partially with respect to a. When you are differentiating sine with respect to a partially, means x is constant. That's why we write the x into cos ax dx on. So x get cancelled, which implies d by dA of f of a is f dash of a equal to integral 0 to infinity e power minus x into cos ax. Now this is directly integrable only, because we have a standard formula for this. This is equal to e power minus x divided by minus 1 square plus a square equal to minus 1 into cos ax plus a into sine ax. From 0 to infinity. Integral of e power ax into sine of bx. So this is for cos bx dx equal to e power ax by a square plus b square into a into cos bx plus b into sine bx. It is a formula. After eliminating the xx, we'll have a simple integral function e power minus x into cos x. So by using this direct formula, we write the integral of this. Now we substitute upper limit, lower limit, which implies f dash of a equal to, for upper limit, e power minus infinity. E power minus infinity is 0. 0 into something, 0. For upper limit, 0. Minus lower limit. E power 0, 1. 1 by 1 plus a square. Sine 0, 0. Cos 0, 1. That way this is minus. This is equal to 1 by 1 plus a square. So f dash of a equal to 1 by 1 plus a square on. F dash of a equal to 1 by 1 plus a square. But we are asked to find the just f of a only. We require the f of a. We are asked to find the f of a. If f of a is this integral, then what is f of a? We know the f dash. If we know the f dash, we can get the f of. To get f of, we integrate both sides with respect to a, which implies f of a equal to integral of 1 by 1 plus a square dA plus integral constant k. Therefore, f of a equal to integral of this is tan inverse of a plus integral constant k on that. But one of the option is contain the tan inverse only. So this is the answer only. F of a is tan inverse of a. And if you want to find the k value, we can use the value of this lower limit also. We can use this lower limit. If you want to find the k value, then we can substitute a equal to, put a equal to 0. For a equal to 0, the above becomes f of 0 equal to tan inverse of 0 plus k. Tan inverse of 0, 0, but f of 0. F of a is this, f of a is this, and f of 0 means here 0, sine 0, 0. This is 0, total integral 0 only, which implies 0 equal to 0 plus k. Therefore, f of a equal to tan inverse of a. Because options directly we can choose without finding this k value. This is about the problem. So we can do this problem by using two methods. One is Laplace transform method and other method is differentiation under integral sign. Differentiation under integral sign like this. Okay, this is one method, Laplace transform method. This is another method, differentiation under integral sign. So this is about improper integral topic. This is improper integral sum. In the improper integral, we have two model problems only. In the improper integral topic, we have two model topics or two model methods. In the improper integral topic, we have two model problems only. Model number 1, model number 2. In model number 1, so far we have done problems are model number 1 only. According to our syllabus, we do model number 1. Model number 2 is not required. Model number 2 means like this. I write one problem here. Integral 1 to 2 root of 1 plus x by x minus 1 power 2 dx. Other problems are integral 1 to 2 x cube plus 1 divided by root 2 minus x dx. Next, integral 1 to infinity e power minus x by x square dx. This problem is another type of model problem. Second model. Here, all three are improper integrals. This is first kind improper integral because of infinite limit. The other two are second kind improper integral. This function is infinite at lower limit. This function is infinite at upper limit, right? So these two are second kind improper integrals, and this is first kind improper integral only. Actually, to check the integral is convergent or not, we have to integrate only. But this function is not integrable. This function is not integrable. This function is not integrable. All the functions are not integrable. So these are called non-integrable functions. If you are able to integrate, that function is called integrable function. If you are unable to integrate the function, that is called non-integrable function only. So we have two models in the improper integral. One of the model is integrable function, other model is non-integrable function. So these problems come under second model. Don't do this model problems. Whatever so far we have done, all those are integrable functions, and these problems come under first model. That's all. This is enough for improper integral topic. This improper integral topic is completed. Next, we start the multiple integral topic. multiple integrals. That is, multiple is more than one integral. In the last two subtopics, we have done the single integral, one integral problems only. Now here we are considering multiple integrals, more than one integral. Okay, just look at this. Y equal to f of x. It is a function of one independent variable only. Function of one independent variable. Already we know the geometrical representation of function of one independent variable only. The function of one independent variable geometrically represents a curve in 2D space, two-dimensional space only. Because this function y equal to f of x will be written as, that is, set of all inputs and outputs are written as x comma f of x only. That is why to represent this function geometrically, we require the two-dimensional space only. Two-dimensional space only. In the 2D space, this is a coordinate of a point only. We plot all these points in space, and if we join all those, we can get the curve in 2D space only. Right? So this function geometrically represents a curve. Similarly, we know that z equal to f of x comma y, geometrical representation only. We have seen the geometrical representation of this in the maxima and minima topic only. The two variable function geometrically represents a surface of some object in space, surface of the some object in space. The space is here 3D space only. For this two variable function, two inputs, one output. The set of all inputs and outputs are written as x, y, f of x comma y, or x, y, z. Here this is as x, y only. X, y, z means three-dimensional coordinate geometry point. So to represent this function geometrically, we require the 3D space. In 3D space, we plot all these points. After plotting all these points, if we join all the points, we can get the surface of some object in 3D space. So the one variable function geometrically represents a curve in 2D space. The two variable function geometrically represents surface of some 3D object in 3D space. Later, we consider the geometrical representation of function of three variables. Not now, later. Okay, already we know this. Here, is a function of x in 2D space. It is a curve. On the curve, let us consider 2 points, capital A, capital B. For this A, the foot of the perpendicular on x-axis is at x equal to A only. For the A point on the curve, foot of the perpendicular is on x-axis is at x equal to A only. For B point of the curve, the foot of the perpendicular is on x-axis at x equal to B only. Now we have some plane region here. This plane region is bounded by the curve, x-axis, and the two lines x equal to B only. Here we have region R bounded by curve, x-axis, and the lines x equal to A, x equal to B only. Right? The area of this region is given by single integral x equal to A to B f of x dx. The area of the region bounded by the curve, x-axis, and the two lines is given by the single integral integral x equal to a to b f of x dx only. It is the integral with respect to x. In this integral dx, we integrate this function with respect to x only. So variable of integral is x, or integral variable is x only. If it is with respect to x, this function should be function of x only. This function should be function of x only. It's a condition. Now, this integral value is the area under the curve f of x above the x-axis, between two lines x equal to a, x equal to b only. So single integral value gives area of the region bounded by the curve x-axis and the lines only. And we extend this to two variable function. Second one, z equal to f of x comma y. Already we know that this function of two variable represents a surface of some object in 3D space only. Some object in space. The equation of the surface is given by z equal to f of x comma y. The equation of this curve is given by y equal to f of x. Like that, equation of the surface of the object is given by z equal to f of x comma. Right? Here, this is a function of one variable x only. It is a function of one variable x only. For this curve, we are getting area under the curve only from a to b. We are getting the area of the curve from a to b only. And we are integrating this with respect to x, means this is the integral along the x-axis. It is the integral along the x-axis from x equal to a to b only. It is the integral along the x-axis from x equal to a to b. Along the x-axis, we are integrating only from a to b, because along the x-axis, this part, along the x-axis, this part is same as the projection of this part of the curve only. Along the x-axis, this part is the projection of this part of the curve only. Projection of this part of the curve only. So we are integrating this function with respect to x along the x-axis from a to b only. The same way here also. Now this is some object in space. Its equation is given by z equal to f of x comma y. And we are considering the projection of this object onto one of the coordinate plane. For this curve, the projection is on x-axis because f is a function of variable x only. That is why its projection is on x-axis only. Similarly, here f is a function of x and y, so its projection will be on xy plane only. It is a surface of some object. Its projection is on xy plane. Why on xy plane means we have taken the equation of the surface as z equal to f of x comma y, because f is a function of x and y. Its projection is on xy plane. Suppose the object is like this. Some object is in space. Its equation is y equal to f of xz. The function is like this, y equal to f of xz. Then its projection will be on xz plane. Xz plane only. Suppose if we have a function like this, x equal to f of yz plane. the function is like this, x equal to f of y z, then the projection of the surface of the object should be on yz plane only. So here also f is function of x, that is why its projection is on x axis only. Suppose for one variable, if you take like this, z equal to f of y, this is y axis, z axis, then the projection of this curve will be on y axis because it is a function of y, like this. Right? Now look at this figure. It is an object in space, its projection is on xy plane. Under this object, above the projection, we'll have some space region only. Under the object, above the projection, we have a space region. The volume of this space region is given by double integral over R f of x comma y dx dy. This is the double integral, more than one integral, that is two integrals, so it is a double integral. The value of this integral is the volume under the object above the projection. And if we compare with this single integral, the value of this single integral is the area under the curve above the x-axis between two lines, so like that double integral value. The value of this double integral is the volume under the surface of this object above the xy plane, only. Both are similar. Single integral gives area, double integral gives volume under the object above the projection. Single integral gives area under the curve above the projection. Under the curve above the projection only. Here under the object above the projection. That's all. Now we extend this two variable to three variable. That will give the triple integral only. This is single integral, this is double integral, and then we have the triple integral only. U equal to f of x comma y z only. For a function of one variable, we are writing the single integral, or single integral is also called ordinary definite integral. This is a double integral. And for three variable, we write the triple integral only. Already we know the geometrical representation of one variable function, geometrical representation of two variable function. Now we'll discuss about the geometrical representation of three variable function. We are going to next page. In general, to write the geometrical representation of this, we give some input values for x, we get the corresponding output values. We get the set of all inputs and outputs together, or it is also same as x comma y. It is just like coordinate of a point in 2D space only. So to represent this function geometrically, we require two-dimensional space. That's why in the 2D space, it is a curve only. In the same way, for z equal to f of x comma y, the set of all inputs and outputs are written as x comma y comma f of x comma y, or it is same as the x, y, z. It is just like a three-dimensional coordinate of a point only. That is why to represent this function of two variable geometrically, we require the three-dimensional space. Right? In the same way, to represent the function u equal to f of x, y, z geometrically, we give some input values for x, y, z so that we get the corresponding outputs. The set of all inputs and outputs together written as x, y, z, f of x, y, z, or x, y, z, u only. If we compare this with the other 2 points, with this point, here it is 4-dimensional point. It is 2-dimensional point, it is 3-dimensional point, it is 4-dimensional point. So to represent this function of three variable geometrically, we require the 4-dimensional space. We require the 4D space. For one variable function, 2D space is required. For two variable function, we require 3D space is we require the 3D space. Similarly, for 3 variable function, we require the 4-dimensional space. We require the 4D space. It is 3D, it is 2D, and this is 4D only. Right? But drawing the graph of the function, is possible for 1D, 2D, 3D on paper only. We can draw the 1-dimensional diagram on paper, 2-dimensional diagram on the paper, 3-dimensional on the paper only. But on paper, we are unable to draw the 4-dimensional figure only. That is why we cannot say directly this represents something only. Let us look at this. Again, we come back to this only. Y equal to mx plus c. Already we know this equation. It is also same as ax by plus c equal to 0. It is a linear equation, 2 variables, or it is a linear equation, 2 variables. It is a linear equation, 2 variables, x and y. Geometrically, this is a straight line. The linear equation in 2 variable geometrically represents a straight line only. Similarly, ax plus by plus cz plus d equal to 0. It is a linear equation, 3 variable. The linear equation 3 variable geometrically represents a plane. Linear equation 2 variable represents straight line. Linear equation 3 variable represents plane. Plane only. Similarly, ax plus by plus cz plus dw plus e equal to 0. It is a linear equation in how many variables? 4 variables only. What it represents geometrically? Linear in 2 variable is straight line. Linear in 3 variable is plane. Linear in 4 variable is not known. But here onwards, we cannot say directly on. That is why we say that here onwards, hyperplanes. Hyperplanes. We don't have particular name only. Higher dimension spaces only. In the higher dimension spaces, we don't have the particular name. That is why we call them as hyperplanes. This is a straight line. This is a plane. Here onwards, we call them as hyperplanes. Linear in 2 variable, straight line. Linear in 3 variable, plane. Linear in 4 variables onwards, we call them as hyperplanes. No particular name. Like that, function of one independent variable geometrically represents a curve in 2-dimensional space. The 2 variable function geometrically represents surface of the object in 3D space. In the same way, the function of 3 variable geometrically represents hypervolume. This is hypervolume in 4D space. Sorry, not this hypersurface. Sorry, hypersurface. We are not written the integral. Hypersurface. This is curve. This is surface. Now here onwards, we call them as hypersurface. So the function of 3 variable geometrically represents hypersurface in 4-dimensional space. 1 variable function curve in 2D space, 2 variable function surface in 3D space, 3 variable function hypersurface only. And using this function of 1 variable, if you write the integral, that is single integral, definite integral, ordinary definite integral. Using this function, if you write the integral, that is a double integral. And using this function, if you write the integral, that is triple integral. Single integral gives area, double integral gives volume, triple integral gives hypervolume. Hypervolume in 4D space. Now we are going back. The triple integral of f of x, y, z is written as 3 integral sign below the integral sign v inside the integral f of x, y, z dv or dx, dy, dz. Single integral gives area, double integral gives volume, and the triple integral gives hypervolume only. This function is curve in 2D space. This function is surface in 3D space. Like that, this function is hypersurface. So because of hypersurface, it is hyper volume only. Because we are unable to draw the graph of this function on paper only. That is why hyper surfaces, hyper volume like this. Single, double, triple only. From all these, we remember one point. We integrate this integral along the x-axis from a to b only. Okay. Next, we integrate this double integral over the coordinate plane only. Single integral is the integral along the x-axis. Single integral is the integral along the x-axis because integral is with respect to x. So along the x-axis we evaluate. It is the integral with respect to x and y. So we evaluate this integral over the xy plane because on the xy plane, the region is the projection of this object only. Similarly, here we evaluate triple integral over the volume regions. Remember this point. Single integral along the coordinate axis. If it is x with respect to x means along the x-axis. If it is y, along the y-axis. If it is z, along the z-axis only. If it is t, along the t-axis only. If it is xy, over the xy plane. If it is yz, over the yz plane. If it is xz, xz plane only. Similarly, triple integral will be over the volume region. Single along the coordinate axis. Double integral over the coordinate plane. Triple integral over the volume regions. Right? The single integral is required to find the area of the region and also volume of the solids. And also we use this for line integral work done. Next, and also we use this integral for length of the curves only. Similarly for this surfaces only, objects only. Also it is useful to find the moment of inertia, mass of a wire, moment of inertia of a wire. Again, it is required double integral is required to find the surface integral to find the moment of inertia of these surfaces or region, mass of a region. And this triple integral is also required the moment of inertia of plane region, volume regions, solid objects on. And this is also required. These three integrals are required to find the line integral, surface integral, next, and also flux on. Indirectly, these three are required for vector integration on. Okay, note point. Just now I told that these integrals are required to find the area and volume only. We are writing that same here. To find the area, we can use the single integral. Single integral means this, integral a to b f of x dx. On. Double integral means like this, double integral over or f of xy dxy. Triple integral is like this. Here onwards, I am taking this single integral as ordinary definite integral. Ordinary definite integral. The short form of double integral is d dot I. Because of the d dot I, we are using the short form of single integral as ordinary definite integral. The short form of triple integral is ti. To find the area, we can use the single integral or ordinary definite integral. To find this same area, we can use the double integral also, but conditions apply. Star or with the condition. Double integral with the condition. To find the volume of the region, we can use the, in general, the volume is given by double integral only. In general, area is given by single integral. But to find the same area, we can use double integral also only, but condition only. Next, in general, volume is given by double integral, but we can find the same volume by using triple integral also. Triple integral means with the condition only. Just remember this. In general, volume is given by double integral. In general, volume is given by double integral. But we find the same volume by using triple integral also with the condition. Later we add the condition. Just remember this point. To find the area, we can use single integral, that is ordinary definite integral, or a double integral. Double integral means with some condition. We can find the volume by using double integral in general, but we find the same volume by using triple integral also with some condition. Later we read the condition. Now next we read the method of evaluation of double integral. Method of evaluation of double integral. In short form, D dot I. Double integral short form is D dot I. Now, in which case 1 is 1. Double integral over R f of x comma y dr equal to integral x equal to a to b, x equal to a to b, integral y equal to c to d, f of x comma y dx dy. Now we have two integral along with the limits. X limits are a to b and y limits are c to d. When you observe both limits, the limits are constants. With these constant limits, we can write this integral in two ways. Integral x equal to a to b, integral y equal to c to d, f of x comma y dx. This is dy, then outside dx, or integral y equal to c to d, integral x equal to a to b, f of x comma y dx, then dy. So whenever the integral limits are constants, that is x limits are constants, y limits are constants, we can write this integral in two ways. Suppose if we consider first one, first we do the inner integral with respect to y. We integrate inner integral with respect to y. While integrating with respect to y, we treat other variable x as constant. That is just like partial differentiation. When you differentiate the function of x comma y partially with respect to x, we treat other variable y as constant. Just like partial differentiation, here we integrate this. So first, if we take this form, first we do the inner integral with respect to y by taking x as constant. After integrating this with respect to y, we substitute the limits in place of y so that we get function of x that will be integrated with respect to x1. Inner is with respect to y, outer is with respect to x1. Or if we take this form, first do the inner integral with respect to x and then outer integral with respect to y. Whatever we choose, we get same value only. From these two, we can set no order here. Whatever the order you follow, we get same value. The order is not important in the case of constant limits only, right? Whatever you choose, you get same answer. Next note point. If f of x comma y equal to 1, then double integral over R f of x comma y dr equal to area of the plane region. That's all. This is about this condition. Inside the double integral, function f of x comma y is 1. Function f of x comma y is 1. Then this double integral is same as a single integral. Whenever function f of x comma y equal to 1, this double integral is same as single integral. That is why The value of this integral is the area of the directly the plane region R. That is why here we can find the area by using double integral also only. So if you want to find the area of this region using double integral, we consider like this: area equal to double integral 1 dx dy. That's all. To find the area of this region R, we consider double integral with the function 1 and we evaluate so that we get the area of this region. This is same as a single integral only. Next, note point number 2. If f of x comma y equal to h of x into g of y. In the differential equation, already we have seen about this function. It is a function of two variables. If you are able to write this function as function of x into function of y, then this is called variables separable form only. We can say the function is in the form of variable separable form only. That is, variables are separated only. Then integral x equal to a to b, integral y equal to c to d, f of x comma y dx dy. This is equal to integral x equal to a to b h of x dx into integral y equal to c to d g of y dy. Like this. Inside the double integral, the function is f of x comma y. The function f of x comma y is in variable separable form. The integrals will be separated like this. According to this integral, we have to integrate first with respect to y and then with respect to x, or with respect to x and then with respect to y. Instead of doing the integral one by one, we can do the two integrals at a time like this here only. So variables are separable, then the integrals will be separated. It is the advantage of it. And this is possible when the limits are constants. Limits are constants, variables are separable, integrals will be separated on. This is about note point number 2 on. Next, case 2. Double integral over R f of x comma y dr equal to integral x equal to a to b integral y equal to phi of x to psi of x f of x comma y dx dy equal to integral x equal to a to b inside the brackets integral y equal to phi of x to psi of x f of x comma y dy and then dx. Right? Now the difference between this and case 1 is, in the case 1 for both integral limits are constants, x limits are constants, y limits are constant, but here only x limits are constants, y limits are functions of x, that is variable limits. Y is in terms of variable x, y is in terms of variable x is in terms of constant a, constant b only. So x limits are constants, y limits are variable limits only. When y limits are variable limits, not only y, x may be variable limits also. One of the variable limits are variable limits, other variable are constants, then you cannot integrate with respect to x first only. We should start the integration with respect to variable limits y and then stop the integration with respect to constant limits x only. That is, here we have order of integration, but in the case of constant limits, no order of integration. Here order is immaterial. We can start with the y, we can stop with x. Here we can start with x, we can stop with the y. No order of integration in the case of constant limits only. But in the case of variable limits, we have some order of integration. That is, we always start with the variable limits and then stop with the constant limits. So always y limits may not be variable limits. Sometimes x limits may be variable limits also. That is over R double integral over R f of x comma y dr equal to integral y equal to c to d integral x equal to phi of y to psi of y f of x comma y dx dy. Integral y equal to c to d, inside the integral x equal to phi of y to psi of y f of x comma y dx and then dy. Right? So x limits may be variable limits or y limits may be variable limits only. In two ways we can write. So under double integral we have only mainly two cases, purely constants and for one of the limits variable limits only. Why only variable limits for one variable and why only two constant limits? Later you will know. While doing the problem you will know the reason for this only. We cannot have the variable limits for both variables x and y. We will have only variable limits for one variable, constant limits for other variable, or purely constant limits for both variables only. So if we have variable limits for double integral, then we should start with integration with respect to variable limits and then stop the integration with respect to constant limits. It is the order of integration. This is about double integral. Similarly, same method for triple integral. We are not writing the triple integral method of evaluation like this. Next, change of variables in double integral. Change of variables in double integral. It is using change of variables in the double integral, we can convert one coordinate system to other coordinate system only. The variables x and y of x, y plane in one coordinate system. The variables x and y of x, y plane in one coordinate system are changed to new variables u and v of uv plane in other coordinate system by the transformation x equal to x of u comma v, or x equal to phi of u comma v, and y equal to psi of u comma v, then double integral over r x y f of x comma y dx dy will be reduced to double integral over r u v f of, in place of x we write the function of u and v, comma, in place of y function of u and v on, into modulus of j into du dv. comma, where j equal to dou of u comma v by dou, sorry, here xy to uv, dou of x comma y to dou of u comma v only. Now here we require the Jacobian of transformation. It is the conversion of one coordinate system to other coordinate system in double integral only. In the case of double integral, that is in 2D case, the particular case is Cartesian coordinate system to polar coordinate system, or polar coordinate system to Cartesian, particular case. Particular case. In the case of 2D or double integral, the particular case is changing Cartesian to polar, polar to Cartesian. Cartesian to polar. To convert Cartesian to polar coordinates, to convert Cartesian to polar coordinates, consider x equal to r cos theta, comma y equal to r sin theta, dx dy equal to modulus of j into dr d theta, and j equal to dou of x comma y by dou of r comma theta equal to r. That is r dr d theta. Therefore, double integral over r xy plane f of x comma y dx dy to double integral over r theta. We replace x with the transformation r cos theta. In place of y, r sin theta in the function into j. Jacobian of transformation xy coordinate system to r comma theta. If you find the Jacobian of this using these two transformations, j equal to r into dr d theta. Change of variables, general coordinate system xy to uv, uv to xy, but here xy to polar coordinate system in a particular case. Similar to this in triple integral, change of variables in triple integral, x, y, z to u, v, w only. In the case of triple integral, the particular cases are Cartesian to spherical, Cartesian to cylindrical only. Right? Now, this is about change of variables. Similar to this, change of variables in triple integral. We are not writing the triple integral. Whatever we have the methods of evaluation of double integral, change of variables in the double integral, we will have same thing in the triple integral also. So triple integral is similar to double integral only. And remember this. In the case of triple integral for variable limits, x equal to a to b integral y equal to phi 1 of x to phi 2 of x integral z equal to psi of x comma y to psi 2 of x comma y f of x y z dz dy dx. All three limits may be variable limits, or sorry, here all three limits may be constant limits, or for two variable limits constant limits, only for one variable limits may be variable limits. But here for first integral constant limits, for second integral variable limits, third integral variable limits. Here z limits are functions of two variable, y limits are functions of single variable, x limits are constants. If we have variable limits, we have a order of integration. The order of integration is like this. First, we should start the variable with the two variable function limits, and then we go to the single variable function limits, and then we stop with the constant limits only. If you like this, if you write the order like this, then do the innermost integral with respect to z by treating other two variables x, y as constant. After integrating with respect to z, we substitute the limits psi1, psi2 in place of z, so that we get function of xy. We integrate f of xy with respect to y, and then outermost integral is with respect to x only. Okay, we start. So this is about triple integral only. In the case of double, we'll have only two integrals. In the case of triple, we'll have three integrals only. Suppose in the case of triple integral, we have variable limits. For two integrals, limits may be variable limits, or for single integral, only variable limits only. So these two may be constant limits, this may be variable limits, or this may be constant, these two may be variable limits. Or only for one integral variable limits, other two may be constants, like this. Different possibilities on it, right? Now let us do the problems on this. Problem number 1. The value of integral x equal to 1 to a, integral y equal to 1 to b, 1 by xy dx dy is. Now it is a problem. In this problem, we are having integral. The two integral sign. If we have an integral with a two integral sign, this is a two integral sign integral. But every two integral sign may not be a double integral. Integral, some function, dx, dx. It is also integral having two integral sign, but it is not a double integral because both are with respect to variable x. Here we have with respect to x, with respect to y. If you have a two integral sign with respect to same variable dx, dx, this is not a double integral, not a multiple integral. It is a twice integral of the function with respect to variable x only. Twice integral, two times integral on it. If you have a two integral sign, some function dx, dy, that is two different variables, then only it is a double integral or multiple integral. In the multiple integral, particular case is double integral only. So in the given problem, we are having two integral sign with respect to x, with respect to y. That is two different variables. So it is a double integral only, right? Now, if it is double integral, observe the limits only. Check for both integral limits are constants, not constants only. Or the variable limits are given, not given, check it on. In this problem, x limits are 1 to a, that is constant limits only. Integral y equal to 1 to b, for y also limits are constants only. For both integral limits are constants. Because of the constant limits, no order of integration. There is no order for integration. In any order, we can do the integration. Let us write all the possibilities. Out of all the possibilities, we choose the simple possibility for writing the value of the integral. Let I equal to integral x equal to 1 to a, integral y equal to 1 to b, 1 by xy dx dy. It is a given integral. Then we write all possibilities. The first possibility, integral x equal to 1 to a, inside this integral y equal to 1 to b, 1 by xy dy dx. Next, second possibility, integral y equal to 1 to b, integral x equal to 1 to a, 1 by xy dx and then dy. In general, these two are possible always. In general, these two are possible always only when the limits are constants. We can consider the first one or we can consider second one. Whatever we choose, we get same answer. But for the same constant limits integral based on function, we can add one more possibility also. The function f of x comma y equal to 1 by xy. Here variables are separable. Function of x into function of y. Because of the variables are separable, we can separate integrals also. The third possibility may or may not possible. That depends on the function. But in the given problem, for this function, we can add the two integrals separately on it. Integral x equal to a to the integral x equal to 1 to a, 1 by x dx into integral y equal to 1 to b 1 by y dy. Like this we can write in two ways. So out of, in general, these two are possible always. In general, these two are possible always, but this may or may not possible. That depends on the function. In this given problem, the variables are separable. That is why we are writing the integral separately on. Out of these three possibilities, the last possibility is simple possible form. In easy way, we can add the integral value directly by evaluating the two integrals at a time only. If you take the first one, second one, first we do the integration with respect to y or x first and then other variable only. But here we do both integrals at a time. That is why this is simple form only. Therefore, integral, that is I equal to integral x equal to 1 to a 1 by x dx, integral y equal to 1 to b 1 by y dy equal to log x from 1 to a log y from 1 to b equal to log a minus log 1. Log 1 is 0. So just log a into upper limit log b, lower limit log 1, 0. That is log b. It is the answer. So limits are constant, no order of integration. Next, problem number 2. The value of integral 0 to 1, integral 0 to x square, x into dy dx is if we compare this problem with the previous problem, you can find two differences only. Based on limits, we have two differences only. It is a double integral. Previous problem is also double integral. Here limits are given. In the previous problem also limits were given. Here the main difference is limits are variable limits. In the previous problem limits were constant limits only. That is one difference. Other difference is in the previous problem limits are specified 1 to a for x only, 1 to b for y. So 1 to b for y, 1 to a for x only. The limits are specified for someone's variable. But in the second problem, limits are variable limits and the limits are not specified for someone's variable. We don't know whether these limits for someone's variable only. So whenever the limits are not specified, also no problem. We can choose these limits for someone's variable only. Now say this integral, the total integral is in terms of two variables. The total integral is given in terms of only two variables x and y. And for first integral limits are constant. For second integral we have variable limits. Now observe this variable limit only. This is with x. This function is with the variable x only. Whenever it is function with the variable x, then these limits for other variable y. That's all. Suppose we have like a 0 to 1 y cube to like this some function dx dy like this only. In this integral, for first integral limits are constant, for second integral limits are variable limits only. Lower limit is a function with a variable y. So here in this integral we are given limits with the y variable. Therefore these limits for other variable x only. Function of x is given, these limits for variable y. Suppose function of y is given, then these limits for variable x only. So these limits for x, these limits for other variable y. Like that here, the variable limit is a function of x, then these limits for variable y. The integral is with y, then other integral is with x only. Like this we can choose only. Right? Whenever the limits are not specified for so and so variable, based on limits we can choose the limits for so and so variable only. Here x limits are constants, y limits are variable limits. So we should start the integration with the variable limits y and then stop the integration with the constant limits x only. It is the order of integration. So first we write the order of integration and then we evaluate the problem only. Let I equal to integral x equal to 0 to 1. Inside the integral, y equal to 0 to x square, x into dy, and then dx. Integral x equal to 0 to 1. While integrating this function with respect to variable y, we treat other variable x as constant because we are inner integral is with respect to y only, but it is only function of x. So write the function of x, the variable x outside. Integral of 1 with respect to y is y from 0 to x square dx, which implies I equal to integral x equal to 0 to 1 x into, for upper limit x square, lower limit 0 dx. The double integral is reduced to single integral. It is the integral with respect to x, function of x. So integrate this with respect to x. I equal to integral of x cube is x power 4 by 4 from 0 to 1. Therefore, I equal to 1 by 4. It is with the variable limits only. Next, problem number 3. The value of integral 0 to 1, integral 0 to y, integral 0 to 1 plus x plus y, f of x, y, z, dz, dx, dy is. So, comma, where f of x, y, z equal to, where f of x, y, z equal to y. If we compare this problem with the previous two problems, it is a problem with the 3 integral sign with respect to 3 different variables z, x, y only. So it is a triple integral. Integral sign with respect to 3 different variables, triple integral only. And the function of x, y is y. Like second problem here, the limits are not specified for so-and-so variable only. Without specifying also, we can choose the limits for so-and-so variable based on the given limits only. The total integral is in terms of 3 variables, x, y, z only. For first integral, limits are constant. For second integral, lower limit is constant, upper limit is function of y. Next, third integral, lower limit is constant, for upper limit, it is a function of x and y. Whenever it is a function of x and y, these limits for other variable z only. So it is an integral for z only. Out of 3 variables, z is completed. Only 2 are left. Next, here it is a function of y. If it is function of y, these limits for other variable x only. X, y are left, and we are given function with y. So these limits for variable x only. If this is for z, this is for x, means this is for y, like this. We can choose the limit for source variable. Now we are at the order of integration. Let I equal to integral y equal to 0 to 1. Inside this, integral x equal to 0 to y, integral z equal to 0 to 1 plus x plus y, f of x, y, z is y, dz, dx, and then dy. Then I equal to integral y equal to 0 to 1, integral x equal to 0 to y. We are integrating innermost integral with respect to z. That is why we have to choose the other variables as constant. So y is constant. Integral of 1 with respect to z is z, 0 to 1 plus x plus y, dx, and then dy. Which implies I equal to integral y equal to 0 to 1, integral x equal to 0 to y into, in place of z, substitute upper limit 1 plus x plus y minus lower limit 0 on dx and then dy, which implies I equal to integral y equal to 0 to 1. Now integrate this. Y is constant, integral of this is we are integrating with respect to x on. The triple integral is reduced to double integral here. So inner integral is with respect to x. Y is constant. Integral of 1 x plus integral of x is x square by 2 plus integral of y is constant x y from 0 to y dy. Y equal to 0 to 1, y into proper limit y plus y square by 2 plus y square lower limit is 0 dy. Next integrate with respect to y. Triple to double, double to single integral. Y into y square y cube by 3 plus y into y square y cube by 6. So this is y square y cube y power 4. By 8 plus y into y square y cube y power 4 by 4 from 0 to 1. Therefore, I equal to 17 by 24. Now we have done 3 problems on multiple integral topic, and in these 3 problems limits were given directly, but always the limits may not be given. Always the limits may not be given. Already we know that double integral will be evaluated over the coordinate plane or over the region, and triple integral will be evaluated over the volume region only. Whenever the limits are not given, then we try to find the limits by drawing the region of integration only. We do that type of problems in the next class, that is tomorrow's class. With this, I stop here. So I stop the today's session, and after this, we'll have a doubt session. If we have doubts, we can ask. Otherwise, we can take rest for next class. Hello.
Hello, sir.
Tell me.
Sir, in yesterday's class, I had a doubt. Sir,
Okay.
in one question you were solving x sine 8x cos 6x dx. Sir, in that question you solved sine 8x and cos 6x, but in that equation there was also an x that you never even considered for once.
No. We have eliminated that x according to property number 7. After elimination of that x according to property, we will have only sine power 8 and cos power 6 only. And we evaluate that sine power 8, cos power 6 by directly ninth property only.
You eliminated it. That part again. Okay, sir. Thank you.
Is it okay?
Yes.
Any doubt still?
No, sir. No, sir. No, sir.
Okay. Hello.
Good evening, sir. Good evening, sir.
Good evening. Good evening. Tell me.
Sir, page number, question number 6, sir, today.
Question number 6. Do you know the page number?
6, sir. That question, page number, sir, I think 70F.
This one.
Sir, sir, this question only, this question. Sir, how we will know that this question is only solvable by this Laplace transform and this differentiation, sir? Any means
Only e power
any
x we can
ways?
integrate that. If it is e power x, we can integrate. If it is sin ax, we can integrate. If it is 1 by x, we can integrate. E power minus e power ax into sin bx, we can integrate. E power x into cos bx, we can integrate. But here we have product of three functions. Exponential is one function, 1 by x is one function, sin is one function. Okay.
Yes, sir. Yes, sir.
If it is, suppose this x is in the numerator. Suppose
Yes,
this
sir.
x is here
Yes, sir.
numerator. We can integrate by taking the two functions as one function, other function as one function. We can integrate only. But this x is in the denominator. When x is in the denominator, we cannot apply the integration by parts formula here only. So we cannot integrate this only directly only.
Okay, okay, sir.
That's why if you are able to eliminate this x, we can do the problem by
Okay,
other
sir.
methods. Tell me.
Okay. Sir, you substitution, sir, that sir, I could not hear actually.
Which one?
Substitution you told, na, sir. If this is
okay,
there,
okay.
then you can substitute by 10 of that's. Can you
If
repeat
any
it again,
integral
sir?
if any integral is in the form of a square plus x square form, then we use a trigonometric identity secant square theta minus tan square theta equal to 1. Because if we shift this other side, we get the 1 plus tan square only. So if you take the x equal to a tan theta, then
Okay,
this
sir.
will be 1 secant square only. Okay, if it is a square minus x square, then use the sin square theta plus cos square theta equal to 1. Got it?
Okay, sir. Okay. Yes, sir.
And
Yes, sir.
also,
Yes.
this
And
this
sir,
problem, integral limits are 0 to infinity. Whenever the integral limits are 0 to
yes, sir.
infinity, possible to evaluate by
Yes,
using
sir.
Laplace transform method. Because Laplace transform is integral 0 to infinity
sir.
e power minus st
And
f of
sir,
t. Hello?
yes, sir.
Hello?
Yes, sir. And sir, last not able to understand how this means single integral is equal to means means surface and double integral is give means volume give rise to volume, because sir here z is not varying, sir, only coordinates are varying. Then how can it be volume, sir?
Now, if you see this, y equal to f of x function. If we give some value to x, we get some value for y. The input and output
Yes, sir.
together written as f of x, x comma
Yes,
f of x, or x comma y. It is just like two-dimensional coordinate geometry point only. So for given values of x, we get the values of y. We write the set of points x comma y. If you plot all these points in 2D, then if you join, we get a curve like that. For z equal to f of x, y, if we give some values for x and y, we get these some values for z. Then we write the set of all inputs, outputs together like this. It is just like 3D coordinate geometry point. So we plot all these points in 3D space and then we join all those points. Then we get a surface of some object only. Got it? Hello?
Got it, sir. Got it. Thank you, sir.
Right. Hello?
Hello?
No, tell me.
So can you go back to that 70th Laplace transform?
70. Oh.
So the Laplace transform. Yes, sir. So here we know that sine AT Laplace transform is like a by s square plus a square.
Yeah.
Then we will then integrate it from s to infinity.
Yeah.
Then a by s square plus a square integration should come 1 by a tan inverse s by a, right?
1 by a square plus s square is 1 by a into tan inverse of s by a. These two get cancelled. Is that okay?
Yes, sir.
Uh,
So then how your answer was coming tan was A by S?
Page number
69.
70, 69.
69, 69.
Uh, sin 80 by t. Okay, okay, okay. This is pi by 2 minus inverse of a by s.
Yes, sir.
Okay. This is cot inverse of s by a. Okay. From this we can write the tan inverse of a by s. Because tan inverse of x equal to 1 cot inverse of 1 by x, the type one.
Sir, how pi by 2 minus tan inverse S by A is equal to cot inverse?
Tan inverse x plus cot inverse x equal to pi by 2 result.
So,
Is it okay?
and yes, sir, and I'm having question. Maximum and
Is it okay? This doubt.
yes, sir. Yes, sir. Yes, sir.
Okay. Again, we are going back to maximum.
No, sir. No, sir. I will just say the question.
Oh,
Short
okay, okay,
question.
okay, okay.
Power sin x. Hello.
Tell me.
So write the question fx, f of x,
F of x equal to
e power sin x
e power sin x
divided by whole divided by
uh,
e power cos x.
uh,
So we have to find the maximum value
maximum value. Is there any interval or only just function or any other condition?
for all x
For all x.
belonging to R.
E power sin x minus cos x. This is f of x. F dash x equal to e power sin x minus cos x into derivative of this is cos x minus plus sin x equal to 0. We equate first derivative to 0, we solve for x only. Right? This exponential never be 0 for any finite value. Then it should be 0 only. Cos x plus sin x equal to 0. So sin x equal to minus cos x. That is tan x equal to minus 1. Then x equal to. What is the value? Sorry. X equal to? For what value of x this becomes? Is it minus pi by 4?
3 pi. Yes, sir, minus pi.
Minus pi by 4. Or if you do like this. In this quadrant, pi by 4 is here only. Minus pi by 4 is here. Next 3 pi by 4 also. Many values are there. Okay. Like this we get the stationary points, many station points because of transcendental equation.
Sir,
That's
and
what I asked. That's what I asked you. That interval is given or given on.
Sir, one more question was there, and find that the function f of x, some function is given, and find whether maxima or minima and where the points. So the function is 2x to the power 4.
2
X power 4 plus y square minus x square minus 2y.
Okay.
The question is written that the function f x y has a relative dash.
The function has
Has a relative dash.
relative.
Yes, sir. Relative.
Any option was given?
Yes, sir. There are four options.
What are
Two
the
for
four?
maxima, two for minimum. For maxima, it was 1 by 2 comma 1.
It was asked to write the maximum minimum value or only maximum point?
So points.
Maximum points.
So other one option.
What is the first option?
Maxima at half comma 1.
Maximum at off comma 1. Okay. Option B.
Minimum at half comma 1.
Minimum at off comma 1.
Option C, maxima at 0 comma 1.
Maximum at 0 comma 1.
Minima at 0 comma
Minimum at 0 comma 1. Okay. Have you solved this?
1.
Do you have the station points here?
Yes, sir.
What are the
So I
station points?
got 1 by 2 comma 1 and 0 comma 1.
1 by 2 comma
1.
1. Okay.
Next is 0 comma 1.
0 comma 1. Have you checked the condition RT minus S square at each point?
Yes, sir. I got two options correct.
Two options.
But it is gate question. It should be only one option. Smart.
What is the RT minus S square value at this point? 1 by 2 comma 1.
So it's so hard for I can't check my own eyes.
Do you have a that solution? That is
Yes,
solution.
sir, I have.
What is the RT minus S square value at this point? 1 by 2 comma 1.
So it's so mashed up that I cannot recognize what I've written.
Okay. P equal to fx 8x cube minus 2x. Q equal to fy with respect to y is 2y minus 2. Next PQR fxx 24x square minus 2 is equal to 0 E equal to FYY 2. At least are these correct? So here, if you solve this, x is common, 2x is common here, 2x is square, and that's 4x
It
square.
these points will only.
Huh?
The points will be same.
Same? Okay, no problem. No need to find points directly. So at 1 by 2 comma 1 are equal to 1 by 4, 6 minus 2, 4. RT minus S square, 8 minus 0, greater than 0. R is also greater than 0. So minimum. At this point, function will have minimum. Next is 0 comma 1 are equal to x equal to 0 minus 2. So minus 2 into 2. RT minus S square is minus 2 into 2 minus 0 square. That is minus 4. Minus 4 means less than 0. When RT minus S square is RT minus S square is less than 0, that is saddle point, neither maximum or minimum. RT minus S square is greater than 0, then depending on R, we can set maximum, minimum only. R less than 0, maximum. R greater than 0, minimum only. When this is less than 0, directly saddle point, neither maximum or minimum only. Equal to 0, we cannot say anything by this method only. So 1 by 2 comma 1 is the correct answer.
Thank you, sir.
Right. Hello.
Sir,
Tell me.
sir, page number 69.
Page number 69. Okay.
Sir, here I didn't understood this question, sir.
This one.
Yeah.
So the problem is integral 0 to infinity e power minus x sine ax by x only. We have a product of three functions in this problem. Suppose integral is just e power ax, we can write the value. If it is sine, we can write the value. 1 by x, we can write the value. Product of these two, we can write the value. Product of these two, e power x into cos also, we can write it. But here product of three functions, exponential sine into 1 by x.
Okay.
Suppose if we have e power x into sine, we take these two together as one function, this as one function, we can apply the integration by parts formula. But here, 1 by x is there. Whenever we have a x in the denominator, we cannot integrate this by using by parts formula. By parts formula doesn't work here only. Is it clear?
Okay. Yeah. Sir, here they have given f of a, and our function is in terms of x.
No. Actually, after the evaluation of this integral, we get the function of a only. Here, inside the integral function is a function of x. A is constant, and integral is with respect to x. And after integrating this function with respect to it, we get function of x, and then we substitute limits so that we get function of a.
Okay.
That is f of
This,
a.
we are not integrating with respect to a, right?
No.
Okay.
The integral is with respect to x only.
Right. And sir, here we get pi by 2 minus tan inverse of s by a. Right. After then cot inverse of s by a, and then after inverting we get tan inverse of a by s.
Yeah. Right.
Okay. Now I understood, sir. Sir, page number 72.
Page number 72. Okay.
Sir, volume integral comes with three integral now.
No.
In second point.
No, actually, single integral gives some value. That value is the area of the region under the curve f of x above the x-axis between two lines a2 and b1. Similarly, this double integral gives the value. That value is the area under this object. Okay, above its projection. This under the object above this. This double is the extension of this single integral only. Here the area is under the curve above the x-axis, like that here. Because on the x-axis, this part is the x equal to a to x equal to b is part of the x-axis is the projection of the part of the curve only. Like that. In the double integral case, here R is the projection of this surface of the object only. Under the object above the projection, whatever you get space region, the area of this, the volume of the space region is given by double integral only.
Okay.
This is 3D. Similarly, this triple integral will give the hyper volume, because for that, if we want to draw the diagram, we require the 4D space only.
Okay. Sir, area and surface area, both are same now.
Area is different, surface area is different. Surface area, that surface is curved surface.
Okay. That is why
this area is only 2D plane region, straight plane only.
Okay. Got it.
Surface area means that comes under whenever the object is given in 3D space, the 3D space or surface may be curved or plane. Okay, that type of area is the surface area.
Okay, for that second option is right.
Yeah.
Volume you have written.
That is 3D object only. But
Okay.
here this double integral gives volume of the region only.
Okay. Sir, in ISRO, one question was asked. There, double integral f of x ds into n cap means normal vector was given. My question is when to use that normal vector and when we should not use. Because I did without normal vector, I got different answer. That answer was also there in option, but that went wrong.
We'll discuss that in vector calculus only.
Oh, okay, that vector part.
You will get that in vector calculus only.
Okay. Sir, in substitution method, we in today's class we substitute x is equals to
b tan theta.
b tan theta. Okay. So can we use every time? Can we use tan theta instead of sin theta and cos theta?
No, if the function is like this: 1 plus x square or a square plus x square, so that we can use 1 plus tan square or 1 plus cot square. In that case only
Okay.
we can use. If it is a square minus x square or 1 minus x square, then we use sine or cos.
Okay, for minus we use sin or cos.
Because sine square plus cos square equal to 1, then sine square equal to 1 minus cos square, or cos square equal to 1 minus sine square.
Right.
That is
Okay. Sir, page number 73.
73. Okay.
So, sir, here case 2. Sorry, this is case 1. We wrote that even if we integrate with respect to above or below, we get the same answer.
Yeah,
Is it
right? Correct answer.
is it always right, sir?
Always right. When limits are constant, no order of integration. We can start with x or we can start with y, anyone. No order of integration.
Sir, in gate question, one question was asked. There you were supposed to find using both the method, and answer was 0.5 and minus 0.5.
That is not same when function is not continuous in the region.
Okay.
This is possible when function is continuous.
Okay. Then we
What
cannot
are the
always go.
region is there here? R is the region. This when you go back this double integral will be evaluated over the coordinate plane. On the coordinate plane we get the region R. That R is a projection of the surface only. So whatever we have function here, that function is defined on this region. Then only we can write the value.
For
Otherwise,
continuous.
Continuous functions.
Okay.
For the same thing, double integral for a single integral also, function is continuous in the interval and the integration is possible. Then only we can write the value only.
Okay.
Like that here also function should be continuous.
Okay. Sir, page number 75.
Mm.
75.
So
Hello.
This is 75.
Sir, here that Jacobian part means we in EMT we used to write for dx dy means dl is equals to what? Dx ax cap plus dy ay cap. So why don't we write directly by that method r dr d theta instead of writing Jacobian?
What do you write? You tell me. Repeat it.
DL is equals to in EMT. Differential length is what? Dx ax cap plus dy ay cap plus dz az cap. And for that spherical coordinates, it is dr ar cap plus r d theta a theta cap plus r sin theta d phi a phi cap. Here, why don't we use that method? Means directly r dr d theta instead of writing Jacobian and all.
No. Here, this is the actual transformation.
Okay.
For spherical coordinates, after finding the Jacobian, we get the r sin theta like that only. In place of Jacobian, we get the r sin theta. Here only r. That depends on the transformation. X equal to r cos theta, y equal to r sin theta. We are getting r Jacobian as. When x and y are different, we get the different Jacobian here in place of j.
When converting from Cartesian to polar, this is standard method.
Actually, the Jacobian is like this: dou of x comma y by dou of u comma v. But here the particular case is this. Here the particular transformation x equal to r cos theta, y equal to r sin theta. For only this transformation, this Jacobian is r only. After simplifying after finding the Jacobian and to simplifying, we get r.
Okay, got it, sir. Got it. Thank you, sir. Thank you so much.
Hello.
Hello.
Sir,
I have a small doubt. Sir, in 74,
74, okay.
It's a variable separable method.
Yeah.
Sir, in this we will find volume only.
This will give volume.
Okay, okay. For area, the fxy is equal to 1. That's the only case.
That's all.
Okay.
In the double integral, the function is 1. Inside the double integral, function is 1. That will give area. Because double integral function is 1 is same as a single integral only.
Yes, sir. Okay.
Because for each x comma y point on the plane region, the heights will be same. When f of x comma y is 1, for each xy, output z is same.
Yes, sir. Yes.
On the top, if we add all these points, then if we join all the points, we get the plane region. That plane region will be parallel to xy plane. So
Yes, sir.
whatever we get the area above this plane region, that will be same as the projection area only.
Yes, sir. Yes, sir. Okay. It will be constant basically.
Yeah.
Yes. Okay, sir. So, sir, it can be fx y is equal to constant. It can also be true for
constant
that.
times of that area
Yes,
only.
yes, sir.
Yeah.
Okay. Right.
Got it?
Yes, sir.
Still, you have any doubts?
No doubt, sir.
Okay. Hello.
Good evening, sir.
Good evening.
Sir, page number 68, sir.
68.
Sir, here if the function is odd, sir, then answer will be zero, right, sir?
No. In the case of odd function for improper integral, we cannot apply that property here.
But in properties, fifth, we have told like
that is only for proper integrals.
Those properties are for proper integrals, sir.
Mainly that properties for proper integrals.
All the properties.
All the properties.
Okay, sir. For this, we need to do in this manner, sir.
Especially, most of the properties works for both. But in the case of minus a to plus a form, for improper integral, only even condition works. Odd condition doesn't work only.
Okay.
The nature of the integral changes. Nature means here convergence divergence changes only.
Okay, sir. So we can't do that, sir. Integral.
No.
Okay, sir. And in 16.9, I think, sir.
16.9.
No, sir. That Laplace.
Okay. Next, I think next problem. This one.
Sir, that formula is there, no, sir, here?
L of sin at by t equal to tan inverse of a by s.
No, sir. E power minus ax sin ax, that is standard formula, sir.
Next problem. This one.
Yes.
This is a standard formula.
So these kind of formula we need to remember, right?
If it is cos like this, exponential cos, this formula. Exponential sign also similar to this, but here minus only, middle one.
Okay, sir. Okay, sir. Sir, in this unit, the important topics are what?
In the calculus, you are
It's
I should not say important, but
like previously you said very, very important is variable separable like that.
In the differential equation topic, we can eliminate some methods also. Just by leaving some methods, we can do some other methods only.
Okay, sir.
But here we cannot say directly. But out of all these subtopics, from the differential calculus, maximum minimum is very, very important.
Okay, sir.
Maximum minimum. If you go through all the previous gate questions, most of the gate questions were asked on this topic, maximum minimum. That to one variable function, maximum minimum.
Okay. Thank you, sir.
Sir, sir, in differential equation, means I just want to know what are the all equations that are present. Means y is equals to mx is a straight line. Y is equals to x square is a parabola. X into y is what? X into y is equals to c is parabola or hyperbola?
Rectangular hyperbola.
Okay, it's rectangular hyperbola. Sir, what are the all equations that are present? Because this question was asked in GATE exam. I wrote parabola for x into y is equals to constant. But that was
actually y equal to x square is a parabola.
Okay, x into y is equals to
X is
constant
a
is hyperbola.
rectangular hyperbola.
Okay. So what are the another equations like this? Because
No, these are the main we come across always. And these are the main important curves and important functions.
okay. So can you just write it down? I will copy it if you.
Mainly y equal to x, y equal to x square, y equal to x cube, and xy equal to 1 or xy equal to some constant. Tan inverse, cos inverse, so tan inverse next to sine function, cos function. Mainly these functions only.
Okay.
You have to remember these functions graphs. That's it.
So for hyperbola, y square by b minus x square by a is equals to c. This also the valid now.
X square by a square plus y square by b square equal to 1. It is an ellipse only.
It is ellipse, and if we put
X square
minus
by
1,
a square minus y square by b square equal to 1. It is hyperbola.
hyperbola. Okay.
So the hyperbola shape will be like this one. That is
X towards
we
x.
call this xy equal to c also rectangle hyperbola. The shape may be like this only, or the shape may be like this, depending on constant value.
Okay.
Because of this is in the form of like this, we are calling this as a rectangle hyperbola.
Okay. Okay. So for ellipse, is there any another equation?
Ellipse, same, only this equation only.
Because one
But
gate question was asked, there they wrote different equations. So
which one?
uh, tomorrow I will come with it. Come with that.
Or we can
because,
send that to my WhatsApp number.
okay, then it will be fine. Sir. Thank you, sir. Thank you.
Okay. Hello.
Hello, sir. Good evening.
Good evening. Tell me.
Sir, in the page number 78F,
78.
sir, in this you said that we have to take the limits, right, sir? Can we take by the order as it is, like dz, dx, dy? So we can take the inner one is as z, then the second one is x, the last one is y. Can we take the limit as it is if the problem?
Sometimes whenever the order is not mentioned, actually based on this order, we can choose the order of integration. Whenever not possible to take these limits for so and so variable directly only. By observation of these given limits, if you are able to choose the limits for so and so variable, we never consider this order of integration only.
Okay, sir.
If you are able to choose these limits for so and so variable directly by observation of limits, we can choose only. Otherwise, we have to observe this order, given order.
Okay, if the limit is with 2 or more variables, then we can go for the z.
Suppose
like
the
that.
limits are like this. Suppose the limits are like this: integral 0 to 1, integral 0 to x, integral 0 to y, like this only. Suppose. Some function z, y, dx like this. Just look at the limits only. 0 to 1 constant, 0 to x variable limits, 0 to y variable limits. When you compare this with the previous problem, in the previous problem for one of the integral limits for 2 variable function, other integral single variable. Whenever 2 variable directly we can choose. But here it is single variable function. It is single variable function. We cannot choose directly only. These limits for so and so variable only. So by observation of these limits, if you are unable to choose the limits for so and so variable, then we have to go for order of integration. According to this order, we choose only. This innermost is for this inner integral, and middle is for this middle integral. This outermost is for outer integral. Like this, we can choose.
If we choose also, we can get the answer, possible answer.
We get the same answer.
Okay, sir. Sir, just from yesterday only, I'm continuing this chapter. So in day 3, you said for Cauchy's mean value theorem, for the first problem, the order is given in open loop, interval is given in open loop, but you taken as first itself closed loop. How, sir?
No. Actually, C value is lying between only open interval. We need to find the value of C between A and B only. So
yes,
in the
sir.
problem, it was asked to write the value of C of Cauchy-Minimal theorem in this interval, means you have to verify the conditions in the closed interval. C should
Okay.
lie between only A and B only, not A and not B. Not actually that in that problem, C was asked, correct or not? It was asked to find the
Actually,
value of C only.
C is asked
It was asked
in
to
the
find the C
Cauchy's
value.
interval.
That is why it was given that open interval only.
Yes, sir. In the problem, it's given as open interval. But
Yeah.
when we doing the problem, you first itself you took that as a closed interval.
Whatever way you are given the function C power x, C power minus x, both are continuous and differentiable in every interval only. That is why in this closed interval A comma B also, this is continuous and differentiable. That is why we took
Based
the
on
closed
the
interval.
function, you took that as closed one.
Yeah.
But if any
According
other
to theorem,
function is given,
both should be continuous in the closed interval. That is why we have chosen one.
Okay, sir.
According to theorem, both should be continuous on closed interval. Suppose any function is not continuous in the closed interval, the theorem will not be applicable.
Okay, sir. Okay, sir. So, is the problem is asked directly Cauchy's mean value theorem, then we can say that as in closed interval.
For checking the continuity only. For differentiable, we should take this as open interval.
Okay, sir.
Okay.
How to check the curve sharpness?
Right.
Okay, sir. Thank you, sir.
Okay.